Shaima, what about you? Shaima?
Sir, I tried, but I couldn't do it properly.
You should have referred the NCERT, na? You have referred the NCERT. So send me whatever you have done. Okay? I will check it after the class on WhatsApp and I will help you. See, whenever you face any difficulty in doing any problem at any time, click a photo, send it to me. Okay. So if it is like working hours, then I will reply within 1 or 2 hours. Okay. And I will not give you the answer completely for sure. Obviously. I mean, there is always a what I can say star mark, or there is always some terms and conditions in the sense that if there is a question which requires complete solution, I will give the complete solution. But if there is some question in which I think that I can give you hints and then you can catch it on, then I will give you hints only. Okay, so most probably I will be giving you hints and asking you to think about those things, think in these terms, think in that term, and that will help you understand it. Fine. So if you have any doubts, please send it on WhatsApp at any time. Okay, if I'm not sleeping, then I will be giving you the answer and hints within 1 or 2 hours. Fine. Chali. So we have done case 1 in the Sharik number 3. Right. We're doing Sharik number 3 and case 1. Let's write case 2. Two sigma bond plus 1 lone pair. Okay, we have 2 sigma bond and 1 lone pair. We did not do this, na? Yes, we have done this.
Sir, we did this.
Oh, we have done this. We did this. Na? Okay, we did this. So this case is completely done. You have to move to Sharik number 4. So in Sharik number 4, we are going to look at the case 1. The first case will be 4 sigma plus 0 lone pair. 4 sigma plus 0 lone pair. That means we will be having a molecule which is having 4 surrounding atoms. What will be the hybridization? Tell me, guys. What will be the hybridization? Hybridization, tell me. Keep your mic on. If you try to speak, then you'll be able to understand more. Okay. What will be the hybridization? Look at the table. We have made a table in which we have written the hybridization. Yes, please tell me.
SP4,
What's that?
SP2.
4 sp.
SP3.
sp3, right? We have an s orbital and there are 3 p orbitals. In total, we have 4 plus p plus p plus p. Since we are using 4 atomic orbital, we will be making how many hybrid orbital? Tell me, how many hybrid orbital will be there? There are 4 atomic orbitals.
4.
After mixing, please answer 4. Very good. 4 hybrid orbital. The hybrid orbital is going to look very similar to the sp and the sp2 type. So this is the hybrid orbital. And when we are going to mix it up, and we are going to have 4 balloons, can you imagine? You have tied together 4 balloons. Can you imagine that?
Yes, sir.
All of you are able to imagine? Pakka?
Yes, sir.
It will look something like this, yes or no? Make sense? Right?
Yes, sir.
Now, the structure will look same. Like, let us suppose this is 1, this is 2, this is 3, and this is 4. Okay? Please try to understand what I am trying to say here. Right now, which balloon is on the top? 1, 2, 3, 4. From the 1, 2, 3, 4,
1.
which balloon is on the top? 1.
1.
So if I put 2 at the top, it will look still the same, right? Yes or no?
Yes, sir. Yes.
If I just rotate it, if I just rotate it and keep the 3 in the top, then also it is going to look the same. If I keep 4 on the top, then also it is going to look at the same. I'm not saying that I'm going to untie it and again then tie again. I have this complete structure after tying, and I just hold the 3 and I am putting it on the top. I just hold the 4 and rotate the complete structure to make 4 on the top. then also it is not going to change. Does that make sense? Yes or no? Please tell me.
Yes, sir.
That means it is a complete symmetrical structure, right? It is a complete symmetrical structure. No matter which balloon is on the top, the rest of the three will be pointing downwards, and your structure will look something like this. You will have A, there's one on top, three balloons pointing downwards. So this is B, this is B, this is B, and this. Fine. So if you're going to see, if you're going to join these dots, fine. Can you see that there is
Sir, you're lagging.
I have how much am I like?
Yes, sir,
Too
you're
much.
lagging. Sir, your voice is lagging.
Just give me a second. What about now?
No, sir, you're not lagging. No.
Fine. Okay. Look at the blue ones. Okay. Please don't write anything now. Please see what I'm trying to say. Look, there is one phase we can say we are making a structure. I'm joining the points. There are two faces. Yes or no? Please tell me. Can you see two faces with the blue line?
Yes, sir. Yes, sir.
As soon as I join this point and this point, there will be two more faces. Yes or no?
Yes, sir.
Can you see that? As soon as I join one more line, there will be two more faces. Can you see that, all of you guys?
Yes, sir.
Anyone who cannot see, please let me know. One face is between this one and this one. The other face is between this green line and this green. Okay. So because it is having four faces, we call it tetrahedral. Hedra means face. Okay. Do you know Hydra? There is one mythical creature named as Hydra. Hydra something. If you cut the head of Hydra, it regenerates. If you cut the face of it's once again Hydra. So that Hydra thing, it has come from, I think so, from the face. Has anyone heard Hydra? No. No one has heard about Hydra. It is a mythical creation. Mythical. It is Hydra only, I guess. It is a many-headed serpent with effective power of regeneration.
Yes, sir.
No,
Yes, sir.
some people have heard. है ना? So that Hydra, polyhedron, right? Polyhedron. If I say Hydra, that means this planaria. Planaria ना? Hydra आ रहा है इसमें तो. Oh my God, planaria, it is a real creature, na? Jacob? Huh? Planaria, it is a real creature, right? It is a
Yes,
flat.
sir.
I'm talking about mythical creature. I'm talking about mythical creature. Maybe it has powers of regeneration. I don't know. But so because it is going to have four faces, that is why it is known as this type of geometry will be known as electronic geometry. Electronic geometry will be tetrahedral. The molecular shape will also be tetrahedral. Bond angle will be 109.5 degrees. So by the way, 109.5 degrees will also be sometimes written as 109 degrees and 30 minutes. 109 degrees, 30 minutes. So because in 1 degree we have 60 minutes, That is why it is 0.5. 30 minutes or 28 minutes, it will be very accurate. For example, you can make many examples from this, but one very special example is CH4, methane, or carbon with only single bond. Okay, if a carbon atom is having only single bonds, then it is sp3 hybridized. Copy this down. Raise your hand once you're done. Waiting for Abir, Ali, Jasleen, and Shaima. Please repeat these things. And whatever we are doing now, please repeat, because this is very, very, very new to all of you. It's very new. Like in a single case, you have to study hybridization. You need to remember the electronic symmetry. You need to remember the molecular shape. You need to remember the bond angle. You need to remember the example. For each cases, there are 5 things you have to remember for each case. We have steric number till 6. I'm not saying that one steric number will have only one case. In single steric number, there will be 3 cases, 4 cases. Fine. So whatever we are doing, you don't have school right now, most of you guys. Please do it. Once we are done with the class, please redo whatever we have done till now. Fine. Now moving on. Case 2. In the above case, we have taken 4 sigma. In this case, we are going to take 3 sigma plus 1 lone pair. So sigma, 3 sigma plus 1 lone pair, we are still in at steric number 4. And if we are at, by the way, in this case, we will be having 3 surrounding atoms, and there will be a lone pair on the central atom. The hybridization in this case will be still what? sp3. Hybridization is still sp3. All of the things are going to be same. Right now, the electronic geometry will also be the same. Where are the electrons? They are at the hybrid orbitals. Where are the hybrid orbitals? In the tetrahedral region. Like that. So here you will be having lone pair. Here I will attach the B, B, and B. Now, if you see, if I join the atoms like this, and one A atom hai, so this is a kind of pyramid you can see. And you can see a pyramid. So the electronic geometry, where are the electrons? The electrons are still at the tetrahedral position. Because when you are going to look at the electronic geometry, you have to look at the where are the electrons. So electrons are here, 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 and here. Same. Electronic geometry is what? Still tetrahedral. But when we are at molecular shape, we are talking about molecular shape. In this case, we have to look at the bonds. Please remember, this is not a bond. This is not a bond. These are the bonds. Now, these bonds are going to make a trigonal pyramidal structure. Why trigonal? What's the meaning of trigonal? The base is of triangle. There's a triangular base and we have a pyramid. Trigonal pyramidal. The bond angle in this case will be, see, this lone pair will be exerting more repulsion because bond pair, lone pair repulsion is greater than bond pair. So this repulsion will be greater, and that's why this will decrease the bond angles between the bonds. It will be less than 109.5 degrees. The case and example is of ammonia, NH3. The bond angle in this case, it is equal to 107 degrees. This is the bond angle for ammonia. Waiting for Abir, Ali, Jasleen, and Shaina. Just waiting for Jasleen now. Right, case 3. In case 3, we are going to take 2 sigma plus 2 lone pairs. So 2 plus 2, we are still at 4 steric numbers. In this case, we will be having 2 surrounding atoms and there will be 2 lone pairs on the central atom. The hybridization is going to be still sp3 because we are still in the steric number 4 case. We are still doing steric number 4, 2 plus 2. The electronic geometry is still going to be the same. That is, but in this case, please see, I will keep the lone pair here. I will keep the lone pair here. This is atom B, this is atom B. The electronic geometry, where are the electrons? They are still at what? Tetrahedral. Electronic geometry is still tetrahedral. But if I look at the molecular shape, then remove the lone pair, right? Because when you are looking at the molecular shape, you have to look at what? You have to look at the bonds. What type of shape is this? We have done this previously also. Tell me, what kind of shape is this? We have seen this.
Linear.
Linear? Linear is like this.
Bench shape.
Bend shape. Very good. Angular or bent shape. Angular or bent shape. Fine. But we have the lone pairs, so we have to keep the lone pairs also here like this. Fine. The bond angle will be obviously what? Less than 109.5 and even less than 109.5, and it will be and even less than 107 degrees, right? Because 107 degree was the bond angle when the lone pair was only one. In this case, we are having 2 lone pairs, so they will be doing more repulsion and they will be decreasing the bond angle of the molecule. This example in this case is our water molecule, H2O. Okay, H2O. Achha, let us predict the bond angle. क्या ख्याल है? Sabiha, Abir, Ali, Jasleen, and Shaima. Let us predict the bond angle. Okay. Here, guys. Here. When there is one lone pair, how much decrease is there in the bond angle? How much decrease? From 109.5, we went to 107 when there was one lone pair. So, what is the decrease in the bond angle? Tell me, guys. How much decrease?
2.5.
2.5. 2.5. So, approximately, we can say that if I have one more lone pair, there will be again a decrease of 2.5. Does that make sense?
Yes, sir.
Yes, sir.
So, what would be the bond angle for H2O according to hybridization? Tell me.
104.5.
104.5 degrees. Now, let us check this. Who will check it for me? What is the actual bond angle for H2O? If you remember, our story started from here only, right? The bond angle of H2O. We predicted the bond angle according to the valence bond theory, and we saw that it was far away. Like valence bond theory, it predicted the bond angle to be 90 degrees, but actually it is how much? Can somebody check and tell me?
Sir, it's 104.5.
See how exact the values are now. Water molecules, we have never seen the water molecules, but the power of theory. And theory से लोग भागते हैं. People don't want to study theory. See the power of theory. You have never seen a water molecule, but we can predict the bond angle of water molecule. Pause here and just appreciate this fact. all that is not complete theory. Like we have, obviously, we need some experimental data. For example, agar 107, if we did not have the value 107, then you would not be able to create 104.5. You know? But 109.5, the tetrahedral, the thing for CH4. If you look at CH4, that can be completely predicted. We don't need anything. We just need hybridization. And in space, if you make tetrahedral, in space, if you make tetrahedral, I mean, this is right now, I cannot teach you this. You can just try it, but I mean, you'll not be very much comfortable with this idea. Like if this is a cube and I put atoms on the alternate corners, so these are the alternate corners, right? These are the alternate corners, and let us remove it. And before that, I will have to put a central atom. No? So this is in the body center, we will have the central atom in the body center. Or uske baad, and I will even join this. Let me join it also. You will not, because it is tetrahedral, it is a 3D structure. So this is the tetrahedral structure. Like you cannot even imagine that this is a tetrahedral structure. But this is tetrahedral structure. This red one, now I will also draw, let me draw the wedge dash thing. So actually, like when I draw the wedge now, so this is coming out of the plane. You'll not be able to imagine this right now. And these two things are in the plane, right? So again, this is a tetrahedral structure. Your mind needs some more time to accept a few more things. Sir, please copy this down, raise your hand once you're done. Like right now, you have to just study 5 things. Like for each case, you need to know the hybridization. For each case, you need to know the electronic symmetry. For each case, you need to know the molecular shape, the bond angle, as well as what? Bond angle ke baad examples also. All of these are what sp3 hybridized. Is everyone done? Yes or no? Please tell me.
Yes, sir. Yes, sir.
Now let us move on to study number 5. Should I do the? Let us move on to study number 5. Select number 5, case 1. Can somebody help me writing case 1? I hope you must be a bit habituated with the format we are following. Tell me what will be the case 1? If steric number 5, so case 1 will be, right? Look at the steric
5
number 4.
sigma bond.
5 sigma and
Bond and 0 lone pair.
0 lone pair. Very good. Now, if we have 5 sigma bond and 0 lone pair, the type of molecule that we want to see is A, that is the central atom, and how many B?
5.
Yes, very good. How many of you were thinking at least this? Can you please tell me, Sabiha? Were you able to think about this 5 sigma 0 lone pair? Abir bataiye. Yes, Abir, were you able to think about this?
Yes, sir.
Ali, what about you?
Yes, sir.
Ali, Jasleen.
Yes, sir.
Okay. Shaima Zainab. Okay, fine. Okay, hopefully, so you are able to. Now, what's the next thing that I will write here after case? What do we write here? Tell me.
Hybridization. Hybridization.
Very good. Very good. Please be attentive in the class and you will be able to remember. What will be the hybridization?
SP3D.
sp3d. sp3d. Okay, now please. I have sphere like this. Valence shell electron pair repulsion theory assumes the atom to be a sphere and the electron pairs are on the what? On the surface. So please see. I will put Now this is also surface, right? This is like far away. This is also far away. Even though they are looking really nearby, but they are far away, right? They are one radius and two radius like this. That is on the back side. This one is on the back side. This one is on the front side. Okay. So I have kept two here. One of the pair of electron I have kept here. One I have kept on the top like this, and the other on the top like this. I have got something like this. Is this kind of look like symmetrical distribution? Yes or no, please tell me. This looks symmetrical on a sphere. Can you imagine a bit, right? So this is known as trigonal bipyramidal. Let me write it now. Structure of this is going to be something like this. A, please see. I have triangle. There is a pyramid above. There will be a pyramid below. That is why it is known as trigonal. Why? Because the base of the pyramid is trigonal. Bipyramidal. Why bipyramidal? There are pyramid above and there is one pyramid below. So I have to put 5. I will put B, 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 and B. By the way, should I show the balloons? And this guy is holding it. So can you see the yellow one is above and below, and the 3 red ones are on a single plane? Can you see that?
Yes.
Right. So this is the balloon structure. Now the electronic geometry. Now this case is kind of very important. Electronic geometry is trigonal. Bipyramidal. We will call this in short PVP. The molecular shape will be still the same. PVP, trigonal bipyramidal. If I look at the bond angle, then in this case we have 2 bond angles. If you look at the bond angles between, by the way, here we have 2 types of bond. This bond, it is known as the red ones. Let me draw it in the red. These red ones are known as axial. And then I will draw C in the blue. These are different. These are known as equatorial. So if I look at the bond angle between the equatorial, this is going to be 120. If I look at the bond angle between axial and equatorial, this is 90 degrees. Right? So I will write, there are 2 bond angles, 120 degree and 90 degree. The next point, there are 2 types of bonds. One is axial, that is, by the way, axial one, they will be facing how many repulsions? Can you tell me? Okay, tell me one thing. Axial one will be facing more repulsion from equatorial, or they will be facing more repulsion axial one. Tell me one. Axial ones will be facing more repulsion from which bond? Equatorial bond or axial bond? I think you will not understand it. Can somebody please turn your mic on? And when we talk now, then it will be easy for others also to understand. Can somebody please turn their mic on? No one. Abir, I have to take name. Abir. Zainab ने mic on कर लिया. Zainab, yes, okay, fine. So Zainab, how many axial bonds do we have?
2.
How many axial? Once again,
2.
2. And what will be the bond angle if I calculate the bond angle between axial and axial?
180.
180. And if I try to measure the bond angle between axial and equatorial, how much is it?
90 degree.
90. So equatorial is closer to one axial than the other axial, right? Because 90 degree will be closer to 180 degree, right? So we have to consider the repulsions of what? We have to consider the repulsion of equatorial. Please see, each axial bond will be facing repulsion from each equatorial, and there are 3 equatorial bonds. So each axial bond will be facing 3 electronic repulsions. And these repulsions are from what? Are from where? These repulsions are from the equatorial bond. Does that make sense? Yes or no? Please tell me.
Yes.
No. Tell me. What is the bond angle between equatorial and equatorial?
1.
What is the bond? 120. And what is the bond angle between equatorial and axial?
90.
9. So we will consider the 90 degree one because 90 degree is going to be closer. Shaima, you will have to turn your mic on. Hana? Just wait here. I will explain, Shaima. Don't worry. Okay. So if I consider equatorial bond, there is a bond angle of 120. But if I consider and axial, it is 90 degree. So equatorial to axial. So I will put the repulsion between equatorial and axial. Each equatorial bond is repelled by 2 axial bonds. Each equatorial it is repelled by the above axial and the below axial. So there will be total of how many repulsions? 2 electronic repulsions. Does this make sense? I think Shaima, can you please turn your mic on? Hello, am I audible? Shaima, your mic is off. Turn it on. Don't use the space bar. Yeah, am I audible, Shaima?
Yes, sir.
Okay. So you did not understand the P repulsion?
No, sir.
Okay, fine. See here. Don't turn your mic off. Keep it on. Actually, you understood one thing, na? That axial bond and axial bond, they have 180 degrees far away. This is 180 degrees. And if I talk about this one, it is 90 degrees. You understood these 2 points?
Yes,
Yes
sir.
or no, Shaima? So I'm neglecting the axial bond because axial bond is very far away from the other axial. Make sense?
So can you repeat?
The axial bond, which is closer. 180 degree will be closer or 90 degree will be closer?
90 degrees.
Okay. So 90 degree will be having more repulsion than 180.
Yes.
Okay. So I can ignore 180 because I have to focus on one which is having more repulsion. So 90 degree is having more repulsion. Okay. Axial bond will be making 90 degree with this one. It will be making 90 degree with this one also. With this one also, it is going to make 90 degree. With this one also, it is going to make 90 degree. Make sense?
Yes, sir.
So how many repulsions?
3.
Got it?
Yes, sir.
Now, I am considering only, now please let us see, why 2 repulsions for an axial bond. Okay, if I am going to take one axial bond. Once again, I have to consider the repulsion between axial and equatorial because it is 90 degree. I am not considering the repulsion between equatorial because it is 120. 90 is less than 120. 91 will be having more repulsion. I am taking one axial bond. So one axial bond. Now this is one equatorial bond. I will take one equatorial bond and there are two axial lengths. So here it is facing one repulsion, here it is facing another repulsion. So one equatorial bond is facing only two repulsions. Now, does this make sense, everyone? Yes or no? Please tell me.
Yes, sir.
Okay. From here we can have to conclude one thing. What can we conclude? Keep your mic on and answer me. If there is repulsion, things get closer to each other or they get far away. What happens when there is more repulsion? Things get far away.
They go far
So
away.
where we have more repulsion in axial or equatorial? Where there is more repulsion, axial or equatorial?
Axial.
Equatorial में तो दो ही है. In equatorial we have only two electronic repulsion. In axial we have three. So which is more?
Axial.
Axial. That is why axial bonds are longer. They get far away because of the repulsion. Axial bonds are longer than equatorial bonds. Does this make sense? Yes or no? Please tell me.
Yes, sir.
Now, for this we are going to take examples. So in examples, we can say that valence electron of A it should be equal to 5. That means we have to talk about group 15. In group 15, we can start with nitrogen, but nitrogen cannot make 5 bonds because nitrogen has only 2 shells. And in the second shell, we can only fill S and P. S can hold 2 electrons, P can hold 6 electrons, 8 electrons. But if we are going to make 5 bonds, that would need 10 electrons. So nitrogen cannot hold 10 electrons. We have to start from phosphorus and arsenic. These are the ones which can be the central atom. Valence electron of A, that is the central atom. If I talk about valency, so the valency of B, the combining capacity of B should be what? 1, which is going to make only single bond. So in that case, chlorine and chlorine can make this type of bond. Examples for this case will be, the specific examples will be PF5, it can be PCl5, it can be ASF5, it can be ASCl5. Now, these are the examples, common examples. Further, when we are going to do some problems, in that we are going to see more examples. Copy this down, raise your hand once you are done. और पढ़ाएंगे इसमें आपको नहीं अभी नहीं पढ़ा. I mean, this is no one is doing JEE and NEET classes here. All of you guys are doing boards only, right? I am not teaching anyone NEET and JEE and this from this batch. Now, I mean, in JEE and NEET, we have to also discuss what happens if we have something like this. We have PF and Cl4, or if we have PF2Cl3, or if we have PF3Cl, PF3Cl2, if we have PF4Cl, in these cases, the fluorine will go to equatorial or axial. This type of discussions we have, like their electronegativity plays a role and things happen. Interesting concept, but let us. Now, does this make sense? Yes or no? Please tell me.
Yes, sir.
Yes.
Moving on. Now, examples are done. We will write case 2. What will be the case 2? Help me, guys.
4 sigma and 1 lone pair.
4 sigma plus 1 lone pair. What type of bond will be there? What type of compound will be there? A and how many D?
4.
AB 4 with 1 lone pair. AB with 1 lone pair. What will be the hybridization?
SP3.
Hybridization. SP? Complete it, Abir. Turn your mic on properly. Don't use the space bar. SP?
SP3D.
Very good. SP3D. So the electronic geometry is going to be still the same. we'll have A. Acha, by the way, now a question arises. Where should we put the lone pair? Because we have two different types of bonds. We have axial and we have equatorial positions, right? So the lone pair will go where? Where there is more repulsion or less repulsion? What do you think is? Wait.
More
Let me come.
repulsion.
Let me complete it. What do you think is more? What I can say, favorable for stability? Is repulsion good or bad? What do you guys think? Repulsion is good or bad? Bad. So we want more repulsion or less repulsion?
Less repulsion.
Less repulsion. Where will we get less repulsion? Axial or equatorial?
Equatorial.
Equatorial.
Shaima, was your answer equatorial?
No, sir.
हाँ इसीलिए हमने रोक दिया था. Now, but you understand it will be equatorial, yes or no? Shaima, now?
Yes, sir.
Okay, that is why I stopped, because if you say something wrong, that will get stuck in your head. Because I have to complete the chain of like logic. No? So once the chain of logic is complete, you will obviously answer one equatorial. I'm the big believer in that. All of you know chemistry, complete chemistry. I just have to ask you correct question. Actually, this is known as Socratic method of teaching. You know Socrates. You know Socrates. Nobody knows Socrates. You have never heard of this Socrates? Abhi?
Yes, sir.
You have heard Socrates. Who else? Plato and Aristotle. You must have heard of Aristotle, right?
Yes, sir.
I don't remember the sequence of their, teacher and student, but Plato was in between. Maybe Aristotle was the first one, then Plato, then Socrates, or it was Socrates, Plato, and Aristotle. I don't remember it. Plato was in the middle one. So this type of teaching in which people use dialogue and ask questions and then conclude things, this is basically Socratic method of teaching. I mean, Socrates was the one who said that each and everybody in this complete world have knowledge of each and everything. You just have to ask the correct question. Now, moving on. B will be here, B will be here, B will be here, B will be here. Oh, so electronic geometry, it is still going to be TDP because the electrons are still situated in trigonal bipyramidal fashion. But if I am going to look at the molecular shape, then it looks something like this. Right? Yes or no?
Yes.
Correct? Tell me what it is.
Yes, sir.
What it is? What is this?
See, sir.
Correct. The molecular shape will be what? Tell me, guys. Can all of you see that? Yes or no?
Yes, sir.
Oh. Why? But I have not taken the lone pair because in molecular shape, I just have to look at the bonds. I don't have to look at the lone pair. Molecular shape will be what? Seesaw. Now, next we are going to write lone pair occupies the equatorial position. Lone pair occupies the equatorial position as there is less repulsion in equatorial position. Now, in this case, please see, we are going to take example. And if I talk about the valence electron of A, then it is making 4 sigma bonds. So this 1, 2, 3, 4, 5, and 6. So valence electron of A should be how much? 6. And the valency of B. Valency of B will be how much? 1. So valence electron of A is equal to 6. Can you suggest one element whose valence electron is 6? Can you suggest an
Oxygen.
element who can oxygen make like 4 bonds, 8 electrons, 9, 10? Can oxygen hold 10 electrons? 4
No.
bond and 1 lone pair means no. So we will go to the next one. Which one?
Sulfur.
Sulfur. Very good. And for valency 1, you can have fluorine or you can have fluorine. Very common example for this, it is SF4. We'll do one more example, okay? Copy this down. Raise your hand once you're done. Waiting for Abir, Ali, and Sabiha. So if I have something like this, see here. A, there is one lone pair, double bond some compound, some element, let us suppose B, double bond some element D, and two single bond with B. This will be also same thing only, yes or no? What do you guys think?
Yes, sir.
Trigonal bipyramidal only, right? So what will be the valence electron on A? Tell me, guys. Valence electron on A.
1.
How many bonds? No. Valence electron on A will be count the number of bonds it is making. अच्छा देखिए यहाँ पर. See the
7.
previous case. How many bond it was making? In the previous case, it was making how many bonds? Oh,
5.
4 bonds. Now this is the lone pair. Ignore the lone pair. Bonds. Bonds is between two atoms only, right? How many bonds?
4.
In the previous case, 4. And one lone pair. So total valence electron was how much? 4 bond plus 1 lone pair. Total valence electron?
5.
6. Yeah. 4 bonds plus 1 lone pair. Pair means 2 electrons, right? Think about the same thing here. How many bonds? How many bonds?
4.
No, not 4. No, double bond. We have double bond also, right?
6.
Consider that double bond and tell
6.
me how many bonds? 6 bonds. 6 bonds and how many lone pair?
2.
2 lone.
1.
1 lone pair, that means 2 electrons, meaning how much? 8 valence electrons. Make sense?
Yes, sir.
Okay. Now we have two different types of elements. Valency of D. It will be 2 because it is making 2 bonds. Valency of B, it will be equal to 1 because it is making 1 bond. So valence electron, we have noble gas, xenon. This is oxygen and this is fluorine. Okay. So the compound is FeO2. How many D? There are 2 D, no? So 2O and Fe. So this is also having seesaw type of shape. So noble gases, they make bonds and they form compounds, but those compounds are very rare and they form compounds only with very electronegative elements such as oxygen and fluorine. I mean, oxygen and fluorine are so electronegative that they can pull electron even from the noble gases. Copy this down. Fe को मिल गया हमने. Why I have written Fe? I have to write F2. XeO2 F2. Then we will do the examples. You will understand even more. But right now, please, I mean, when I will be doing the problem examples, so we are taking right now itself. Is everyone done? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Done. All of you done? Anyone still writing? No one's writing. Now, keep C. C sigma plus 2 lone pairs. The type of compound we will be making in this case will be what? A, B, C, and there are 2 lone pairs. The hybridization in this case will be still the same, sp3b. The geometry and everything will be still the same. A, C in the plane, one above, one below. Right. So the 2 lone pairs will be still in the equatorial position. Here we'll keep one B. Here we'll keep one B. Here we'll keep one B. Electronic geometry, trigonal, bipyramidal. And this, if you can see, it is like modified T shape, right? Can you see that it is T shape?
Yes, sir.
If you look at the bonds, no, don't look at the lone pair when you have to. Okay, it is T shape. So see, you don't have to remember most of the shapes. You don't have to remember. You try to see that, like the formation of that particular compound, and automatically you will know what is the molecular shape. Okay, so if I talk about the valence electron in A, tell me valence electron in A. How many valence electron?
7.
Very good. In A, there will be 7. We have 3 bonds, 4, 5, 6, 7. 2 lone pairs, na? 2 lone pairs will be having 4 electrons. So this will be chlorine. Chlorine is chlorine, bromine also. I mean, chlorine does not make because chlorine becomes very small and it cannot hold 3 elements like in there. And valency of B is equal to 1. So we get fluorine and fluorine as the surrounding atoms also. One of the compounds that we can make in this case is ClF. These are known as interhalogen compounds, halogen making compounds with themselves. So ClFT is going to have this type of structure. In this fluorine is going to be what? In this fluorine is going to be the central atom. We can have one more. Shape, not shape. Rather, we can have one more example in which there is one double bond. So if I remove one B from here, and I add a double bond B here, and in this case also you will see that the valence electron in A, it will be how much? How many valence electron?
8.
Very good. 8. So which element? Which element?
Xenon.
Then. Very good. And the valency on D? 2, right? Oxygen. And for B, we have fluorine. So the compound will be, we have FeOF2. Okay. How many of you guys are feeling like your brain is going to pop out? Is anyone feeling like that? No one now? Okay, fine. What, Sabiha, you are raising hand for what? You have completed or your brain is going to get pop out? Your head is going to pop out. Sabiha, why are you raising hand? Are you done, Sabiha? But see, like there are very few things which come like in a single reading or in a single study. Like if you have any new friend and if you meet for the first time, it's most probable. I mean, most probably you will not be remembering their name, right? You forget their name if you meet them for a single time. What do you guys think? Is that correct? Yes or no?
Yes,
Yes.
sir.
Right. So how can you expect to remember everything from a single class? You have to do one revision, right? One revision you will do when, like just after the class. And I will also suggest before coming to the next class, you have to do one reading once more. So you have met your friend 2 times. When the half yearly will come, you will meet it once again. If there is any UT in between, you will meet it once again. If there is any test in Learnivio, if you give it, most of you guys, I don't know why you don't send the test. Fine. But if you are going to give a test for the Learnivio test also, then you are going to meet one more time. Before the pre-boards, I think you have model examination, something like that. You are going to meet it once again. Then till the final, you will be best friends. What do you guys think? Hmm? Right? Like when the final examination will come, you will be almost like best friends. Yes or no?
Yes.
No.
Yes, sir.
Hard to say. Hard to say, sir. The vibes are not good. I am not getting good vibe from this friend. No, no. You will get good vibes. Don't worry. You will get good vibes slowly. But the only criteria is that you have to give it time. If you don't give it time, then things will evaporate very easily. Can you please raise your hand once you're done? We'll move to the case 4. Everyone is done? Ali, how are you feeling? Ali,
Yes, sir.
how are you feeling? Are you all fine?
Yes, sir.
Yes, sir. You're fine. Thank God.
Yes, sir.
2
I'm
sigma,
fine.
2 sigma plus P lone pair. The compound is going to be AB2 with P lone pairs. Sir, how many valence electron? Tell me from here itself. I'm taking a kind of leap, but I guess some people can answer. How many valence electron on A? How many valence electron on
8.
A? Very
8.
good. See, you're already best friends. sp3d. I mean, if you predict something without, for example, if you know somebody like just because you stay with them for a longer time, you know their dislikes and likes even if they have not told you, right? And that's the definition of best friend. Now, no one told you the valence electron, and you already know the valence electron. So you can tell me example. Let us leave it. Tell me example. Tell me an example. Ah, complete compound. Tell me about a compound which will be an example of this case. Chaliye. I'm taking a leap of faith. I know you are best friend. Tell me. You have identified A. I know that. Most of you people have it on your brain. What is A?
Xenon.
Xenon.
Most of you guys have that on your brain. Xenon. What will be B? What will be B? Let's check the pattern. Yes, Zainab.
Fluorine.
Fluorine. What will be the example? XeF2. XeF2. See, you guys are already best friends. Okay, na? The lone pairs are still going to be in the equatorial position. The electronic geometry, it is still going to be trigonal Bipyramidal. Okay. Any guess about the molecular shape?
Linear.
Very good. Just like a straight line, we don't have to look at the lone pair. We only have to look at the bond. It is linear. Example तो आप लोगों ने पहले ही बता दिया. Fe F2. If I talk about the bond angle, it will be equal to 180 degrees. Raise your hand if you're done. This is the best part. Like many of the students, they can now guess. I mean, they can now predict what we are going to teach, what will be the examples. Like your brain is completely now, like it is kind of like maturing now with regard to this valential electron pair repulsion theory, which is a headache for most of the students. Like if you have done chemical bonding in your school, then you must know what type of headache this valential electron pair repulsion theory is. That like what people do, वो उल्टा करते हैं. SF6 octahedral SF6 of XeO2 F2 XeO2 F2, it will be seesaw SF4 seesaw SF4 seesaw, but the way is not that, right? Now we will write steric number 6, but try to focus, try to answer things, and try to think about things logically. Don't force too much on your brain. For example, see what I like how I want to teach is that most of the things is like this. Okay. Two people eat in one plate biryani. Two people eat in one plate biryani. What did I say? Two people eat in? Me.
What?
Two people eat in one plate biryani. Once again. Two people eat in?
One plate biryani.
Two people will eat in one plate biryani. Four people will eat in?
Two plate biryani.
That's how I want to teach. If you start thinking, then you may get confused, right? Four people,
Yes.
I don't know. Somebody will eat more, somebody will eat less. If you start thinking in that manner, like if you start overthinking things, then it will get complex and you will not be able to answer. So what I tried is that you don't force too much, don't try to think logically, like whatever your brain is saying. And that is why I pause also, because sometimes I have not framed the questions very correctly. So I reframe the question so that you will get me the right answer. So steric number is 6. Steric number is 6. In steric number 6, I will not write the hybridization again. For all the cases of steric number 6, the hybridization is going to be sp3d2. I think you guys are now mature enough to understand this. We will take the case 1. तो आपके दिमाग में बन ही रहा होगा. Case 1. Like all of you must be saying case 1. Tell me, what should I write? Case 1. जोर से. More people. I need some more answers. माइक ऑन कर रहे हैं, सिर्फ बोल नहीं रहे हैं कोई. I don't want the mic. I want somebody to speak also, na. Shaima, Abhi, keep your mic on. Tell me. Bolo.
6 sigma bond and 0.
6 sigma plus
0 lone pair.
Zero lone pair.
0 lone pair. What type of compound will be seen in the case?
AB6.
Bolo. AB6. Give me an example. Give me an example. I need example. डर गए बच्चे.
SF6.
अच्छा बोलो नहीं. Very good, Shaima. Shaima, did you know this example or you made this example? Tell me.
Sir, I remember it from.
अरे यार remember वाला नहीं चाहिए हमको. नहीं, previous week कितने? School or right now only?
So from your class.
My class? I have not taught this, right? Did I
So you
ever
had given
say
this as examples before.
SF6? Where did I say SF6?
Electron deficit, something like that.
What's that? That's electron. But can you guys think? 6 sigma means how many valence electron? Anybody else got SF6 in their mind? No one. That was a leap of faith that I took. Let us now study. So the most symmetrical way of putting 6 hybridized orbitals will be one above, one below, and 4 on the plane. I hope you don't need balloon for this. I mean, I can show balloon. I just have to Google it. We'll be having B, 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 we'll be having B. Electronic symmetry. This is known as octahedral. Sir, why octahedral? Because it is going to make 8 faces. I will try to show you guys 8 faces. It is easy. Can you see one face? Can you guys see one face? Yes or no?
Yes, sir.
Acha. You may be seeing 2 faces, right? Yes or no? 2 faces, right?
Yes.
The rectangle, but that rectangular one will not be seen because below also will be having faces, na? So that rectangular one will not be seen. Now you can see one faces. Now can you see 2 face?
Yes, sir.
Can you see the 2 face now? Acha. Can you see the 4 face now? Can you see the 4 face?
Yes, sir.
One on the right, one on the back. One on the right, one on the back. Can you see that?
Yes, sir.
Okay. So 4 faces above, 4 faces below. That is why it is octa. Most people they are like, but sir 6, sir 6, it will be hexa. Octa, why it is octa? Because पूछेगा आपको ऐसा confuse कीजिएगा. After the vacation, you go to your classmates and then this is the 6 now. It should be hexa. It is octa. Octahedral. The molecular shape will also be octahedral. Molecular shape will also be octahedral. All the bond angles in this case is going to be 90 degrees. All the bond angles will be 90 degrees. Okay. Now we are going to take examples. One example will be simple S because sulfur is going to have 6 valence electrons and B will be monovalent, so it will be SF6. We can have one more example in which we are going to make double bond, one double bond. How many valence electron now? In A, how many valence electron will be there? How many valence electron in the A now? Nobody knows.
7.
7.
7. 7 means you can have halogens, bromine. D will be divalent, so instead of D, what will I write? Dr. D, what will be D? Double bond. Who makes double bond? Who makes double bond?
Oxygen.
Oxygen. And B will be the fluorine, BrOF5. If I have one more double bond, you can see where the things are going. I have one more double bond. Tell me. Make a leap of faith. Think think 2-3 steps ahead. Tell me the compounds directly. Think a few steps. Like I have done you like the same pattern BrOF5. Similarly, huge expectation, but I think some of you guys can tell me.
XeO2.
XeO2
F4.
F4. Did you know this or did you make this? Shaima?
I made it.
Made it, na? See, you can make it. All of you understand this now? Yes or no? Please tell me. Abir,
Yes.
most of you, Zainab, most of you would have come till XC. At least till XC you were there. Yes or no, Zainab?
Yes, sir.
You made the complete compound? या फिर कहाँ तक पहुंचे थे आप? Till where did you reach? अच्छा, you have XEO तक you reach. Okay, fine.
Yes.
Yes, Zainab?
Yes, sir.
Ah, okay. So, very good. Raise your hand once you're done. Case 2. एंड काफी हो गया। देखिए हम पढ़ाते रहेंगे ना, अगर हम पढ़ाएंगे तो टाइम तो कम लगेगा थोड़ा, लेकिन वही सवाल पूछने में टाइम ज्यादा लग जाता है। केस 2 इज 5 sigma plus 1 lone pair. The compound will be AB5 with 1 lone pair. It will look something like this. A and all the bonds are same, but generally people put it the lone pair in below because we can then make the compound and it can have some shape, and the shape is square pyramidal. We have square, then we can make a pyramid like this, right? This is square pyramidal structure. The electronic geometry, it is still octahedral because electrons are in octahedral manner. The molecular shape rather, it is square pyramidal. So, give me an example. Tell me an example then for this case itself. Example, guys. How many of you now have recognized the central atom? Central atom.
Phosphorus.
So how many valence electron in the, how much, what's enough? Can you please tell it again? Keep your mic on.
Shell atom is phosphorus.
How many valence electron?
5.
7.
7.
7, na Zainab? Think. Zainab, got it, Zainab?
I forgot to add
7.
here.
You forgot that. Right. So it will be not
Bromine.
chlorine, bromine. Very good. Bromine. And B will be what? Monovalent. सिंगल बॉन्ड कौन बनाता है भाई?
Fluorine.
क्लोरीन. BrF.
Fluorine.
ठीक है, चलिए डबल बॉन्ड करते हैं। डबल बॉन्ड के लिए एग्जांपल बताओ। देयर इज वन डबल बॉन्ड। बोलो।
BrOF4.
डबल बॉन्ड आ गया, डबल बॉन्ड आ गया।
Xe.
वैलेंस इलेक्ट्रॉन अबीर। मेक सेंस अबीर?
Yes, sir.
xenon एंड देन कंप्लीट, कोई दूसरा कंप्लीट करो। श्यामा ने xenon बोल दिया, आगे बोलो।
Oxygen.
ऑक्सीजन और व्हाट एल्स?
Fluorine.
हाउ मेनी फ्लोरीन?
1. 4.
4.
4 ना, तेरा 4 सिंगल बॉन्ड्स नहीं, 4 फ्लोरीन। XeOF4। कितना मजा आ रहा है। खुद से आप लोग आंसर बना रहे
सर डबल बॉन्ड में B ही है कि D लिखा रहता है?
मतलब डी कर सकते हैं, वो तो जस्ट अ मैटर ऑफ शोइंग थिंग्स। मतलब आप समझ रहे थे ना डबल बॉन्ड मतलब, समझ में आ रहा था आपको?
Yes, sir.
आ रहा था, हाँ था। वो तो ऐसे तो बी कोई नया बच्चा देगा सर, बोरॉन तो सर 3 बॉन्ड बनाता है सर, बोरॉन आप 1 बॉन्ड बना दिए बोरॉन का। बट वो तो हमारे बीच की बात है ना, दैट बी इज अ मोनोवैलेंट व्हाट वी हैव ऑलरेडी कंसीडर्ड इनिशियली। आई मीन दैट इज व्हाई आई डोंट टेक बी के लिए जनरली ना लोग उतना नहीं होते कि बोरॉन होगा, लेकिन सी लिख दो तो कार्बन नजर आता है बिल्कुल। आई डोंट नो व्हाई इज दैट, दैट इज आई डोंट टेक सी यूजुअली, मतलब एक बार हमने ले लिया फिर हम छोड़, आई इग्नोर दैट। चलिए लास्ट केस है, ऑल ऑफ यू डन राइटिंग, सुनो।
Yes, sir.
Yes.
पहले
Yes, sir.
कितना ज्यादा लिखना पड़ता था उसमें, मतलब समझा समझा के। नाउ अब आपकी लोग बस देखिए, बॉन्ड एंगल्स आर नॉट इंपॉर्टेंट इन दीस केसेस, दैट्स व्हाई वी आर नॉट राइटिंग बॉन्ड एंगल्स, ओके। केस 3, 4 सिग्मा प्लस 2 लोन पेयर ना, हाँ 2 लोन पेयर। ये भी 4, 1 लोन पेयर है, 2 लोन पेयर है। Above and below will be loan pair. All the B atoms are in the electronic geometry, it is still octahedral, and the molecular shape it is still no, now it is pink, it is square planar. All of these atoms are in one plane, like even the A atom is in one plane, it will be square planar. Now you know what I'm going to ask, right? All of you know what I'm going to ask. Tell me, बताइए।
XeO2F4.
Is it?
O2 कहाँ से आ गया? सिंगल बॉन्ड से भी तो सर।
XeO2.
Yes, very good. XeF4. By the way, we cannot make even double bond now, because if I make double bond, the valence electron will be more than 8. Right? It will be 9 valence electron. 9 valence electron कहाँ से लेके आइएगा? We have group 18 only. So Xe4, that's it. You have done till hybridization. Vesper theory आप लोग कर पाएंगे अभी? कर लेंगे आप लोग। क्या? Sorry?
Done.
Done now. Okay. Just give me a second. I will assign assignment, and then you all can go. अच्छा लगा आज सबको? अबीर, शाइमा, जैनब,
Yes, sir.
थोड़ा कॉन्फिडेंस आया कि मिस्टेक हो सकती है?
Yes, sir.
Yes, sir.
आपको तो लगता है, जब तक सवाल नहीं बनाओ तब तक तो लगता ही हो जाएगी, सवाल जब नहीं पाएगी हो जाएगा, लेकिन धीरे धीरे। सबिहा, अली, यू गाइस अंडरस्टूड?
Yes, sir.
आपको क्या मतलब जवाब ज्यादा आ नहीं रहे थे, पूछ रहे। जसलीन, व्हाट अबाउट यू? आप भी काफी चुप है जसलीन आज। जसलीन, यू अंडरस्टूड थिंग्स?